Hello, friends. So in previous videos, we looked at a bunch of different data visuals. And in a couple of videos, we skipped a question. We're now going to go back to those questions. So with the dot plot, we had found all this information previously. If you don't remember or don't know how to do that, make sure you go back to that video. Our final question was, if 280 people saw this movie while it was at this theater, based on the percentages in the sample, how many people can we expect to have been between 16 and 19, including those ages? So a couple things to unpack here. First, what are we looking for? Between 16 and 19, including those ages. So between 16 and 19 inclusive means we're going to be working in this section. So first we want to count up how many people are in that section. Count up how many X's are in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 people between 16 and 19 of our sample, of our group. Then we are going to divide that by the total, which we had found earlier was 20 by just counting up all the data values. So dividing 15 by 20 gets us 0.75. Or 75% of the people who saw this movie were between 16 and 19 inclusive. To find that number out of a larger number, so what we have here is a sample. Now we want to estimate how much out of the population. So if 280 total people saw this movie, we want to guess how many were between 16 and 19 inclusive. And the way that we do that is multiply. So we multiply our decimal that we just found by the total that we're looking for. So 0.75 times 280, we get about 210 people were between 16 and 19 that saw this movie. Similarly, scrolling a bit down here to our bar graph. We'd answered all these questions before. So our final question, if we ask another 100 people about their favorite fruit, how many would say strawberries? So we found earlier that the percent of our sample here that chose strawberries as their favorite fruit was, well, this kind of uglyish number. But we're going to do the same process. So we found that 29 out of 112 people sampled really like strawberries. So we're going to take that decimal that we found, the 0.2589, and we're going to multiply it by the another 100 people. When we do that, we get 25.89, but we can't have 0.89 of a person, so we're going to round up to about 26 people out of those 100 would say they prefer strawberries. And then finally down here we have a data visual we didn't get to in an earlier video, called a circle graph or a pie chart. So the first one that we have up here represents the favorite colors of kindergarten students in a school. So first we're going to assume that the numbers shown represent how many children like each color. So first we're going to find the total number of children asked. And the way that we do that is just by adding up our numbers. If we're assuming that 28 people like green, and 24 people like yellow, and 32 people like blue, and 61 people like pink, we just add all those up to find how many total students were asked. And I believe we get 145 children. Further, if we assume that the numbers shown represent how many children like each color, find the percentage of the children who like green the best. So similarly, green was 28, and we divide that by our total, 145, and we get 0.19, or 19% when we move the decimal place 2 spots. Number 3 here is important. Can we assume that the numbers shown represent the percentage of children who responded? Why or why not? The answer is no, because percentages are out of 100. We found that our total here was 145, which is not 100. So if we ever have a circle graph that adds up to something more or less than 100, it's not percentages. It is just the number of results. So this circle graph does have percentages. It also talks about favorite colors of children, but it's a different group. So we've got 38% of this group chose green, 40% chose red, and 22% chose blue. If there were a total of 350 students polled, how many like blue the best? We're going to treat this like the ones we did above with the dot plot and the bar graph, where we're going to find 22% of 350. Now, to do this calculation, I recommend changing the 22% back into 0.22, and of indicates multiplication. So we're doing 0.22 times 350, and we get 77 kids like blue. Same idea. If there were a total of 350 students polled, how many prefer red? So 40% of 350. Again, change that percent back into a decimal, and the of means multiplication. So we're going to multiply 0.40 by 350, and we'll get that a total of 140 students, 140 kids like red the best. And that's that.